the Pythagorean theorem, and you do that using the coordinate plane. There are a couple parts that you need to know first, so we're going to get that written down, and then we're going to do some problems. So the first things are, when you have a right triangle, the side that is across from the right angle mark, that is the longest side, and it's called the hypotenuse. So when you hear that word, you can kind of see the right angle symbol looks like an arrow pointing at the hypotenuse. So the hypotenuse, we usually use the letter C to talk about the hypotenuse. The other two sides are called legs. And because addition is commutative, meaning the order doesn't matter, it doesn't matter which one of these is A or B. That can change. They can go back and forth. And the Pythagorean theorem says that if you have a right triangle, if it is a right triangle, then a squared plus b squared equals c squared. This is the Pythagorean theorem. You should pause the video now and make sure that you have this diagram written down neatly, this theorem written down neatly. And I recommend that you use color and make it somehow similar to mine. That will draw your attention to it. All right, welcome back. I assume that you just made your notebook look nice, since this is an important concept. If it is a right triangle, then a squared plus b squared is equal to c squared. So we're going to look at this using the coordinate plane. We want to know how long these segments are. And in order to do that, we're going to build a triangle. So we know this to here can build a triangle. Now something else to look at would be the coordinates of the points. That will just kind of give you an idea later about how we're going to derive something else. Okay, so those are the coordinates of the endpoints of our blue segment. Now, in order to use the Pythagorean theorem to figure out how long this is, we can clearly just count even how long this side is. 1, 2, 3. That side went from -2 to 1, so 3 spaces. This one goes from 5 to 1, and that's 6 spaces. 1, 2, 3, 4, 5, 6. All right, now we have enough information to use the Pythagorean theorem. I recommend, especially in the beginning of learning something new, that you write the formula down every time you use it. All right, so A and B, it doesn't matter which is which. 6 squared plus 3 squared equals. And what we don't know is the length of the hypotenuse, C. So we'll put C squared. Remember, squared means something times itself. So 6 squared means 6 times 6, which is 36. 3 squared means 3 times 3, which is 9. And that equals c squared. So you can see we're just using the order of operations to simplify this expression. We're going to add these together now. Now, one of the weird parts is that we need to get the c alone, but right now we have c times c. So we're going to use the inverse operation, which is the square root. When you take the square root of something squared, you just end up with it. So c squared, the square root of that is c, and the square root of 45. So we're going to leave it like this for now. We're going to find the decimal equivalent. In a couple weeks, I'm going to show you how to simplify this. But for now, we're just going to leave it in radical form and decimal form, approximately 6.7. That means approximately. So C is approximately 6.7 units long, and that is the same as the square root of 45. All right, let's do it again for this segment. First, we'll find our coordinates. So -1, 2, 3, 4, down 1, 2, 3, 4, 5. And this one is 0, -2. So let's build a triangle. How far up is this? Well, we can count 1, 2, 3, but also -4, or sorry. Yeah, sorry, I was looking at the wrong thing. 5 to -2 is -5 to -2 is 3 spaces. All right, this way we have 4 spaces, which is the same as -4 to 0. So we have two sides, the legs, and we can use the Pythagorean theorem. A squared plus B squared equals C squared. A and B, we already know, and we're looking for C. 3 squared means 3 times 3, which is 9. 4 squared, which is 4 times 4, is 16. And now we're going to add 9 plus 16 is 25. Again, to simplify, we're going to take the square root of both sides. So C equals the square root of 25. And the square root of 25 is equal to 5. I have that memorized, but you can use a calculator to do that. All right. I want you to figure out the length of a segment with endpoints 2, -7, and 5, -4. So based on what we just did, it would make sense to draw a graph and plot the points. 2, -7, 3, 4, 5, 6, 7, and 5, 1, 2, 3, 4, 5, -4. So we want to know the length of that segment. So let's make it do a little triangle. This way we went up 3 and over 3. It's kind of slopish like that. All right, and we're going to use that with the Pythagorean theorem. A squared plus B squared equals C squared. And substitute in our numbers. 3 squared again is 3 times 3, which is 9. And 9 plus 9 is 18. And now we need to take the square root of both sides. So the square root of 18 is equal to C. And that's also approximately equal, if we use our calculator, to 4.2. So this is in radical form. This is in decimal form. All right, I would like you to work on the problem that I would give you and then enter your answer and come back. All right. Now, what happens if we have coordinates like this? This would not be fun to graph. I am not drawing a graph that big. So we want to kind of think about, well, what did we see when we did it before? So let's put the coordinates back on this problem. All right. You can see that the change in the x coordinates, 2 to 5, is 3. And the difference in the y coordinates is also 3, from -7 to -4. That's the difference in them. And so difference, that word, indicates subtraction. So if we look at the x coordinates, we can figure out how far apart they are by subtracting them. So I'm just going to draw a random triangle and put these coordinates on them. All right, we want to figure out the length of this side, but they're so far apart. So we're going to look at the coordinates x's first. Remember, x tells us the horizontal change. So we're going to subtract those. Negative 320 minus 128. And that gives us negative 448. Now, that's how far apart they are, but since it's a distance, we're just going to change it to positive. They are 448 spaces apart. How many spaces apart are our y coordinates? If you think about it, to get from negative 510 to 0 is 510 spaces. And from 510 to 97, again, we're going to subtract, but we're going to keep the positive answer, is 607. So the vertical change is 607. And now we can do the Pythagorean theorem. With our huge numbers, and we'll find out how long that piece is. We're going to add those together. And like before, take the square root. So C equals the square root of this huge number, which is approximately equal to 754.4. And that is kind of an annoying process to do. And so what happened is we can use the Pythagorean theorem to discover the distance formula. But before we do that, I want you to try the problem on the next slide, and we'll talk about it in a minute. All right, so we want to find, this is the distance formula now. So you may want to pause the video and take a minute to write this part down. All right, welcome back. We are going to find the length of a segment with endpoints x1, y1, x2, y2. So like before, we would need to kind of make this into a triangle so we can look at it. Here we have x1, y1. We don't actually know the coordinates. And we want to know how long is this segment, the segment that passes through those points. Well, just like before, we need to figure out the difference in them. So for this leg, we would have x2 minus x1. We're going to take our x's and subtract them. That will give us our horizontal distance. How far are those apart? And we're going to do the same thing with our y's. We want to know how far apart are they. So we take the difference. And then we need to use the Pythagorean theorem. So let's say the first one is x2 minus x1 squared plus y2 minus y1 squared equals c squared. Now this looks kind of weird, but it's the same exact process we did on the other problems. Since we can't simplify any of this because it's not exactly the same, we're going to take the square root of both sides. So c is the same as the square root of x2 minus x1 squared plus y2 minus y1 squared. And this is actually called now the distance formula. But usually we use d for distance. So you can see the Pythagorean theorem and the distance formula are actually the same thing, just in a different format. Pause the video, make this look important. All right, we're going to use the distance formula twice. You need to know that sometimes these questions will say how long, what is the length, how far. Those are all indications that you might need the distance formula. Another indication is that you will have coordinates. You cannot use the distance formula without coordinates. And just like before, I recommend that you write the formula each time before you use it. I actually usually just write x minus x and y minus y squared like that instead of putting the little subscripts because I don't care which order we go in. All right, so here are our x coordinates and here are our y coordinates. So let's use it. The distance is the same as the square root of x, negative 11, minus negative 6, plus y minus negative 7 squared. All right, and I'll color code this so you can see. Those are our x's, and here are our y's. All right, now we're going to simplify. Remember, when you have two negatives in a row, you can just change them to a positive. So we have negative 11 plus 6, which is negative 5 squared, plus two negatives make a positive. Negative 1 plus 7 is 6 squared. Now, still doing the group, we have 25 plus 36, negative 5 squared, and 6 squared. 25 plus 36 is 61. So the distance of the segment with endpoints here and here is the square root of negative 61, which is approximately 7.8. All right, one last example, and then you're going to do some practice of both the Pythagorean theorem and the distance formula on your own. So there are x's and our y's. X, y, x, y. The distance formula is the square root of x minus x squared plus y minus y squared. So x is 15 minus the other x is 3 squared plus y is 7 minus the other y, negative 2 squared. Using the order of operations to simplify our groups, we have 15 minus 3, which is 12 squared, and 7 minus negative 2, that changes to a plus, 9 squared. Still doing our group under the radical and exponents, we have 12 squared, which is 144, plus 9 squared, which is 81. Add 144 plus 81 is 225. So the distance is the same as the square root of 225, or the square root of 225 is 15. All right, try the last problem on the next slide, and then you're done. Just check the other practice that we have available on Google Classroom. Bye.